Welcome back to the deep dive. We are cutting straight through the noise today, wading into the world of aquaculture, and focusing on a really central, critical question.
Yeah, are we really managing, sustainably this massive global reliance on species farmed outside their native homes?
Exactly. It's a deep dive into dollars, dinner plates, and, well, potential disaster. We're working through a major new study.
Right, one that finally tries to quantify the true global footprint of this whole industry. The paper's called Non-Native Species in Aquaculture, Burgeoning Production and Environmental Sustainability Risks. The lead author is Francisco J. Oficialdegui and colleagues, just out in 2025.
Okay, so our mission here is to really get a grip on the staggering scale of this reliance. I mean, we're talking trillions of dollars in production value, and then try to weigh that against the often hidden but very real costs, environmental damage, potential invasions, that sort of thing.
And the context for this is, well, it's immediate global necessity, isn't it? Aquaculture is now the absolute foundation of global aquatic food production.
Yeah, I saw that stat. First time in 2022, it actually overtook capture fisheries.
That's right. Overtook capture fisheries as the main source of animal protein from water. It's essential, truly essential, to feeding the world.
But that inherent risk, it seems so baked into the system. Aquaculture is the main way non-native species get introduced, right? Mostly just escapes.
Yeah, usually unintentional escapes.
Yeah.
And here's the rub. The industry picks species because they have these high-performance traits like rapid growth. They reproduce a lot.
High fecundity. Yeah.
Exactly. And those are the exact same traits that make them potentially devastatingly successful invaders if they get out.
So it's like a conservation tightrope we've been walking for decades, really.
Pretty much.
Okay, let's unpack this study then. Quantifying something, this huge hundreds of species, the whole globe, sounds like a monster data job. How did they actually do it? What tools did they use?
Well, they needed to combine sort of the benefit side with the cost side, right?
Right.
So for production, they used the gold standard. The FAO fisheries and aquaculture statistics, it's known as FishStatJ.
Okay, FishStatJ.
Think of it like the global census for who's farming what, where, when, how much money they're making. It tracks production quantity way back to 1950 and the economic value since '84.
Okay, so that gives us the economic baseline, the benefit side. But tracking the costs, the environmental damage, that's notoriously hard. How did they tackle that?
Yeah, that's the challenge. They turned to the InvaCost database.
InvaCost, I've heard of that.
Right. It's basically the most comprehensive global database we have of the monetary costs linked specifically to biological invasions.
Ah, okay.
And crucially, using InvaCost let them standardize all those reported costs.
Yeah.
From different times, different places, different currencies.
So you get it all on the same page.
Exactly.
Yeah.
Into consistent 2017 US dollars. That gives you a real apples-to-apples comparison.
That standardization is absolutely key, yeah. And the scope, how wide did they cast the net?
Immense. Their analysis covered 560 species farmed globally across 204 territories.
Wow.
It's arguably the most complete picture we've ever had of this global farming practice.
Okay, let's get straight to the scale then. The volume and value just from these non-native species. It sounds like it's pretty breathtaking. What are the headline numbers?
Yeah, they really are. So since 1950, 160 species, that's exactly 1/3 of all species ever farmed in aquaculture, have been farmed outside their native range.
1/3, okay. And the total amount produced?
Total volume, 571.6 million tons of product.
Million tons. And the value, the dollar figure.
That volume.
Yeah.
Valued at USD $1.2 trillion.
Jillion, with a T.
With a T. Non-native species make up a full 33%, 1/3 again, of total global aquaculture production since the 1950s. We're talking about an economic engine that literally runs on species moved around the planet.
Okay, but here's where, for me, it got really interesting. The study talks about shifts across different types of farmed organisms, taxonomic groups. While native species might still dominate fish overall, non-natives apparently totally dominate within two major high-value groups.
They absolutely do. It's quite striking. Non-native species account for a staggering 67%, 2/3 of total algae production, and 55% of total crustacean production globally.
Half of all crustaceans farmed.
Yeah. It really shows that when the industry finds a winner, like certain seaweeds or shrimps, they scale it up globally, whether it belongs there or not, basically.
And the real aha moment reading through this seemed to be the explosive rate of growth they found, specifically in non-native crustaceans. Driven mostly by shrimp farming, I guess.
Oh, definitely. The speed is what's fascinating. They calculated this astonishing increase Over 11,000%.
11,000%.
In non-native crustacean production, just since the year 2000, compared to the 20 years before that.
That's incredible growth.
It is. That production volume jumped from about 500,000 tons in the 80s and 90s to nearly 58 million tons between 2000 and 2019. It's a massive, relatively recent boom, really fueled by global demand for shrimp.
So if you look at the map geographically, which countries are leaning most heavily on these non-native species for their aquaculture output?
Well, globally, it's pretty widespread. Non-native production volume was actually higher than native production in 115 countries.
More than half the countries surveyed.
Yeah, 56%.
Yeah.
And you see major reliance in places like North Korea. They report 90% non-native production. Chile is huge at 77%.
Yeah.
Even France at 66%.
Chile, that immediately makes you think salmon farming, right?
It absolutely should. It's a perfect example of this whole economic flow.
Yeah.
The production of Atlantic salmon, salmo salar, and rainbow trout Oncorhynchus mykiss, neither of which are native to Chile.
Right.
That industry generates an estimated economic value of something like $60 billion for Chile.
60 billion just from those two non-native fish.
Yeah, the profits are real, they're highly concentrated, and they genuinely drive national economies.
That is just an astonishing volume and value. But okay, generating $1 trillion, that doesn't usually come without some kind of price tag attached.
No, it doesn't.
How did the researchers move from quantifying all that production to looking at the damage, the risks?
Yeah. Right, this is where we shift from the, let's say, success story to the liability ledger. And the risk isn't theoretical, right? It's baked into the species they choose. Well, about 40%, that's 62 out of the 160 species farmed outside their native range, are already classified as harmful invaders on regional or global lists.
40% are known troublemakers already.
Yeah, we know they cause problems.
So we have this $1.2 trillion benefit side. Now, what about the documented monetary cost? How bad is the damage that's actually been reported and put into dollar figures?
Okay, so overall, 27 of these farmed non-native species have some documented monetary costs in the InvaCost database.
27, okay.
When they look just at the 9 major aquaculture species driving most production, they documented at least $6.4 billion in total global costs over time.
Wait, $6.4 billion total compared to a $1.2 trillion industry value? That economic disconnect feels huge. Why does the documented cost seem so, well, small in comparison?
It really does seem small, and it points to a monumental failure of accounting, you could
Yeah.
say. A big part of it is how they calculated the most reliable cost figure. To be really conservative, methodologically sound, they focused only on highly reliable, observed costs they can really pin down.
Right, the stuff they could prove.
Exactly. Using that strictest measure, the documented costs for just 8 key species, it amounted to a relatively tiny $287.2 million between 1960 and 2020.
Okay, 287 million versus 1.2 trillion. That is a disconnect.
It is. And it's almost certainly a massive underestimate. Think about reporting lags, the difficulty of tracking environmental damage in monetary terms. It's just incredibly hard to capture the true cost.
Sure. And how are those costs, the ones they could track, broken down? Was the money spent, like, fixing the damage after the fact or preventing it?
Oh, overwhelmingly reactive.
Yeah.
75.2%, 3/4 of those documented costs were categorized as damage.
Damage meaning?
Meaning resource losses. So negative impacts on local fisheries, loss of ecosystem services, that kind of thing. Only about 24%, less than a quarter, was spent on proactive management, like control actions, trying to stop the spread.
So we're mostly paying for the cleanup, not putting up fences?
Pretty much. Dealing with the wreckage, not prevention.
Let's make this really concrete. Can you give us a vivid example?
Yeah.
What kind of ecological destruction do some of these high-performing farmed species actually cause when they get out?
Sure. Take the common carp, Cyprinus carpio. It's farmed widely. When it escapes, it's not just another fish. It's like an underwater bulldozer.
How so?
It roots around in the mud at the bottom, looking for food. And doing that, it physically alters water quality, stirs up sediment, makes the water cloudy, increases suspended solids.
Turbidity, yeah.
Right. And that physical change can suffocate native aquatic plants, mess up spawning grounds for native fish. It impacts the whole system.
It really shifts the entire ecosystem structure.
Exactly. Or think about the red swamp crayfish, Procambrus clarkii, another famous invader farmed in some place.
Right, the crawfish.
Yeah. It's a fierce predator, especially on things like amphibians and mollusks. It can drastically alter wetland habitats just by eating everything.
Yeah.
And critically, it can carry pathogens,
Oh.
like the crayfish plague fungus. Aphanomyces deishi might not kill the red swamp crayfish, but it can wipe out entire populations of native crayfish that have no resistance.
Wow, so they're vectors too.
Mm-hmm.
This brings us to a really crucial concept the paper highlights, this idea of externality. If the costs are so hard to quantify and mostly reactive, who's actually footing the bill for this multi-trillion-dollar industry's side effects?
Well, that's the key, isn't it? The use of non-native species in aquaculture is presented as a classic example of externality, meaning the entities that get the primary benefit, the big aquaculture companies making profits, or maybe low-income countries getting vital food security and jobs.
Okay.
They are often not the ones bearing the main monetary or environmental costs. Those costs are pushed outside the transaction. They're externalized.
So the damage to, say, a traditional native fishery in China from escaped Nile tilapia, or the cost of trying to manage common carp invasions in North America, that gets paid for by the taxpayer or the local fisherfolk, not the company that originally profited from farming the fish.
Precisely. Costs usually end up falling on, other resource users like fisheries, or they're borne by government authorities who have to fund management actions. It fundamentally distorts the real cost-benefit picture.
Which brings us right to the policy angle. It sounds like there's this massive tension playing out globally between economic necessity feeding billions and environmental conservation.
That tension is definitely reflected in policy differences. You see more industrialized countries, say, in the EU or the USA, imposing pretty stringent regulations on moving species around.
Right.
And that has, frankly, slowed the growth of their aquaculture sectors compared to other regions.
And
Conversely, many low- and middle-income countries often prioritize immediate food security and job creation. Understandably, perhaps. And that tends to lead to higher production growth, often with more lenient environmental policies. They might feel they simply can't afford not to use these high-performing non-native species.
And the paper notes these weird regulatory contradictions, too, even in places with strict rules. Like, species we know are invasive can sometimes still be farmed under specific exemptions.
That's correct. It's a fascinating point. The paper mentions how, even in the EU, species that are officially recognized as invasive, like rainbow trout or the Pacific oyster.
Both major aquaculture species.
Huge ones. They can still be farmed under specific regulations. Why? Because their economic viability is so massive, their supply chain so established, they essentially get carved out, exempted from the general invasive species rules. Economics basically trumps ecology in those specific high-value cases.
Okay, so given this huge risk, this externality problem, what immediate management solutions are proposed? How do you tackle this without just shutting down a critical food industry?
Well, the low-hanging fruit is enhanced biosecurity. Better protocols on farms to prevent escapes, and just rigorous stakeholder awareness, making sure everyone involved understands the risks.
Are there frameworks for this?
Yes. The research highlights risk analysis frameworks like NSARS, the European Non-Native Species, and Aquaculture Risk Analysis Scheme. It's a tool to evaluate the potential risk of introducing a new non-native species before it happens. And it's being used now in places like Turkey and China.
Assessing risk up front. Makes sense. But if the current model, relying so heavily on non-natives, isn't fully sustainable long-term, what's the bigger structural shift needed for the industry?
The real long-term pathway has to involve incentivizing a serious shift towards using native species.
Okay. How?
Well, it means either focusing R&D and investment on native species that are already sort of domesticated, or maybe investing heavily in domesticating new native species that could fill some more market niches.
So finding local alternatives.
Exactly. For instance, the paper notes that farming native pennade shrimps, local shrimp species, is entirely feasible in many regions. It could be done despite the current overwhelming global reliance on that one non-native, the Pacific white-leg shrimp.
Right. But how do you actually force those entities benefiting so much, the trillion-dollar producers, to internalize the costs they're currently sort of dumping onto society and the environment?
Well, that brings us back to that classic economic tool, the polluter pays principle.
Okay.
The idea is you could explore environmentally related taxes levied specifically on enterprises farming high-risk non-native species.
A kind of invasion risk tax.
Something like that. It would be a mechanism to legally require those who profit from activities posing significant environmental risk to actually pay towards mitigating those risks or covering the costs of the resulting environmental damage. It tries to close that massive gap in the accounting we talked about. So, yeah, we got to circle back to the central duality highlighted by this research, don't we? non-native species. They account for nearly 40% of global aquaculture production. They fuel a $1.2 trillion industry, feed millions. That's huge.
Huge benefits, undeniable.
But this entire system carries these considerable, often ignored or underestimated environmental and long-term socioeconomic risks. Risks that are currently being subsidized, essentially by the public and the environment itself.
It's stark when you put it like that. We're seeing massive, massive economic benefits driven by species that are simultaneously classified among the worst invaders in the world. It really feels like a constant choice between a short-term, maybe necessary economic win and potential long-term ecological disaster.
That's the tension.
Which brings us to a final, maybe provocative thought for you, the listener, to mull over.
Yeah.
If economic necessity and conservation priorities seem constantly at odds in the sphere, is something like the One Health framework the only way forward? You know, that idea demanding real cross-disciplinary collaboration, governments, farmers, ecologists, economists, all working together. Is that the only viable path to manage non-native aquaculture sustainably? Or will short-term economic gains always, inevitably, outpace our long-term sustainability efforts?